In section 3, we're going to talk about the last method we can use to solve a quadratic, and that's using the quadratic formula. So the quadratic formula, as long as you have a quadratic in the form ax squared plus bx plus c equals 0, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the nice thing about the quadratic formula is it can be used to solve any quadratic. So unlike the previous two methods we talked about, factoring and completing the square, where there are limits on factoring because a quadratic has to be factorable, and completing the square only really works well in certain conditions, you can always use the quadratic formula. Another part about the quadratic formula is the discriminant, which is b squared minus 4ac. And we'll talk more about what the discriminant is later on in the notes, but the discriminant is specifically the number that's underneath the square root. So let's go ahead and do some examples where we solve a quadratic using the formula. So we have x squared minus 4x minus 2 equals 0. So the first thing that I'm going to do is identify a, b, and c. So a is the number in front of x squared, which in this case is 1. B is the number in front of x, which is negative 4. And c is our constant, which is negative 2. It is important that you keep the signs of a, b, and c when you identify them. So we're going to have x equals negative, and then b, which is negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times negative 2 all over 2 times 1. So notice how I use parentheses around b here, which is also extremely important. Especially when it gets to doing the b squared part underneath the squared part underneath the square root. So negative 4 is going to become a positive 4, plus or minus, and then when I square negative 4, I get positive 16. So whenever you square b, you should always end up with a positive number, which is why I put the parentheses. And then negative 4 times 1 times negative 2 is going to give positive 8 all over 2 times 1, which is 2. That then becomes 4 plus or minus the square root of 24 all over 2. Now I need to simplify the square root of 24. So 24 is not a perfect square, but I can simplify it. So 24 is 6 times 4. 4 breaks down as 2 times 2, and 6 breaks down as 3 times 2. So there is a pair of 2's I can bring outside. So it becomes 4 plus or minus 2 square root 6 all over 2. Because the 3 and the 2 multiply back together. Now that I've simplified the square root, I look at all of my numbers and I see if they can simplify. So that's the 4, the 2, and the 2, which are all divisible by 2. So I end up with 2 plus or minus the square root of 6. I cannot simplify the number underneath the square root with the 2 because it's underneath the radical. So my final answer is that x equals 2 plus the square root of 6, and x equals 2 minus the square root of 6. For our second example, we have 2x squared minus 4x minus 3. So again, I'm going to identify a, b, and c. So a is 2, b is negative 4, and c is negative 3. So we're going to have x equals negative 4 plus or minus square root of negative 4 squared minus 4 times 2 times negative 3 all over 2 times 2. Negative 4 is going to become 4 plus or minus, and then I'm going to get 16 plus -4 times 2 is -8 times -3 is positive 24 all over 4, which becomes 4 plus or minus the square root of 40 all over 4. So now I need to simplify the square root of 40, which I can break down as 10 times 4. 10 is 5 times 2, and 4 is 2 times 2. So another group of 2's. So we'll have 4 plus or minus 2 square root 10 all over 4. Because then this 5 and this 2 are going to multiply back together. So again, I look to see what can simplify. 4, 2, and 4, all divisible by 2. So we're going to get 2 plus or minus the square root of 10 all over 2. And that is going to be our final answer. So for our last example on this page, we have x squared plus 1 equals x. So in the previous two examples we did, the quadratic was already set equal to 0, so I can identify a, b, and c and start right away. But in this case, it's not. So my first step is going to be to actually subtract x. So we get x squared minus x plus 1 equals 0. Now I can identify a, b, and c and use the quadratic formula. So a is 1, b is -1, c is 1. So we're going to get x equals -1 plus or minus the square root of -1 squared minus 4 times 1 times 1 all over 2 times 1. -1 will become +1 plus or minus the square root of 1 minus 4 all over 2, which becomes 1 plus or minus the square root of -3 all over 2. So we know previously from previous sections that if I have a negative underneath the square root, my answer is going to automatically contain I. So we're going to get 1 plus or minus I square root 3 all over 2. The next step would then also be looking to make sure that my square root is simplified as possible. And 3 can't simplify, so this is going to be my final answer. 1 plus or minus I square root 3 all over 2. So our next example, we have x squared plus 25 equals 8x. So similar to the last problem, my first step is going to be to subtract that 8x, so we get our quadratic equal to 0. So you have x squared minus 8x plus 25 equals 0. So a is 1, b is -8, and c is 25. So we're going to have x equal -8 plus or minus the square root of -8 squared minus 4 times 1 times 25 all over 2 times 1. -8 is going to become 8 plus or minus the square root of 64 minus 100 all over 2, which becomes 8 plus or minus the square root of -36 all over 2. So the nice thing here is square 36 is a perfect square. So I know if I take the square root of 36, I'll get 6. So the fact that it's a negative just means that my answer is going to contain I. So it becomes 8 plus or minus 6I all over 2. And then 8, 6, and 2 are all divisible by 2. So we get x equals 4 plus or minus 3i. Okay, so our last example, x minus 1 times x plus 2 equals 5. So there's actually quite a few steps I have to do here in order to use the quadratic formula. The first step being that I have to go ahead and distribute into the parentheses. So x times x is x squared, x times 2 is 2x, negative 1 times x is negative x, negative 1 times 2 is negative 2, and then equals 5. Combining my like terms, I get x squared plus x minus 2 equals 5. Now I have to subtract that 5 so that it is equal to 0. So we get x squared plus x minus 7 equals 0. Now I can use the quadratic formula. So a is going to be 1, b is going to be 1, and c is going to be negative 7. So we're going to have x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 7 all over 2 times 1, which is negative 1 plus or minus the square root of 1 plus 28 all over 2, which becomes negative 1 plus or minus the square root of 29 all over 2. And 29 is a prime number. I cannot simplify it. So this is going to be our final answer. So the last thing we're going to talk about is the discriminant. So the discriminant can actually help us determine the type of solutions our quadratic is going to have. So remember, the discriminant is b squared minus 4ac. So if I know what the number underneath the square root is going to be ahead of time, I'm going to know what type of solutions I'm going to have. So there are 4 technical different types of solutions. So b squared minus 4ac can be greater than 0. So it can be positive. So there are actually 2 different types of answers when it is a positive number. The first type is if it's a positive number and a perfect square. That means there are 2 rational solutions. So what that means is that I can take the square root, I'm going to get a number, and I can go ahead and add and subtract that number from whatever negative b is and divide by 2a, and I'm either going to get 2 whole numbers or 2 fractions or a combination of a fraction and a whole number. So those are what we call rational solutions. The second case is if you get a non-perfect square. That leaves us with 2 irrational solutions. So like the last example we did, we ended with 29 underneath our square root, which is not a perfect square, so it still contained a square root in our answer, and anytime our final answer still contains a square root, it's considered irrational. The next case is that b squared minus 4ac is less than 0. When that happens, we have 2 complex solutions. So those are our solutions that contain I. So in every time you have a negative underneath the square root, I is going to be part of your answer. So that's what happens when b squared minus 4ac is less than 0. The last one is when b squared minus 4ac equals 0. Now we didn't do an example of this, but this is the one time you can get one answer, and it would be one rational solution. So what happens is you take the square root of 0, which is 0, so you don't have to do negative b plus or minus anything. It just becomes negative b over 2a, and that's just one number, and obviously it's either going to simplify to a whole number or it's going to stay as a fraction, which is where we get one rational solution. Let me know if you have any questions about the quadratic formula, whether it's identifying A, B, and C, plugging them into the quadratic formula, or if it's about the discriminant.